And notice that those that are added to it are getting smaller and smaller if we're coming in from the middle and to go out.
Right, and if you're coming from the outside, it's getting larger.
Yes.
Now, what I'm seeing here, I'm seeing like a baby giraffe and an adult giraffe.
Yes.
And it seems to me like the baby is a replica of the adult. So from a small giraffe to a larger giraffe.
Okay, so sizes. And look at the Adidas logo. When I look at the quadrilaterals at the top, I notice that the sizes increase going upwards, or it could come down going from largest to smallest.
That's true.
Yes, interesting.
Now, if we look at these spoons, clearly I'm seeing where the sizes of these spoons, these measuring spoons,
Yes.
is getting larger.
Okay, so we have small to large and large to small, depending. Right. Oh, these dolls.
Yes.
And they're arranged in order from smallest to largest.
That is true.
Yes.
And finally, we have the picture of two eyes. Now, I noticed that in one eye, the pupil is very small.
Yes.
But in another, the pupil is very large. Now,
Yes.
Nikisha, what do you think would have happened for the pupil to change from
Inside.
small to large?
All right. Just to think about the cat, you've had cats around. When I was growing up, I had cats, and I
have
always
one now.
noticed that in the days the cat's pupil is very small. That means daytime where there's lots of light, so the pupil becomes small. And in the nights, however, the pupil just expands and fill up the eyes. So I'm realizing that in darkness, the cats see better because the pupils are so wide. So I'm looking here, the pupils are dilated. When it's dilated, there is less light.
Right.
And when it's undilated, there's a lot of light. So
So
that's
you
the
see?
black spot in the eye.
The science coming out in math class today.
Awesome. So basically, these have been examples of enlargement in our world.
In our world. Wonderful.
So mathematics is everywhere.
Yes, it is.
Okay, so let's look at these two objects, drawings here, and do some investigation, make some observations.
All right, so let me start off.
Yes.
So I am looking at these two triangles, and I notice that they appear to be right angle triangles.
Okay.
There it is. All right, so let me tell you what else I observed.
Go ahead.
So I am seeing that for the line segment PQ, it seems to be 2 units long.
Yes.
And for PR, it seems to be 3 units long.
Okay.
If I move over to my image, I can see that P prime, Q prime, that's going to be 6 units long, and P prime, R prime, 9 units long.
Okay.
Is there any relation?
Any relationship? I heard you mention that PQ, first of all, you spoke about object and image.
Right.
When based on previous lessons, we would have realized that the object is the shape that would be going under transformation, and the image would be what would be produced.
Okay.
So in terms of the relationship, I noticed that they would be proportional because, as you said, PQ is 2 units on the object, and on the image, P prime, Q prime is 6 units.
Right.
And that would be 6 would be 3 times 2.
So is this going to happen with PR and P prime, R prime?
Well, let's continue to investigate.
Okay, so earlier I said this would have been 3 units,
Yes.
and that would have been 9 units.
Yes.
So yes, I'm seeing that 3 multiplied by 3 would give me 9. Okay, wonderful.
So we can say that the length of the line segments, corresponding line segments, are proportional.
Awesome.
Okay.
And you know what else I realized?
What?
So I'm seeing that the order of the vertices, P, Q, R, they're in the same order.
Oh, you're correct. And that's interesting and that's important.
Very much so. So let's summarize. So both are right angle triangles.
Yes.
Corresponding lengths are proportional.
Yes.
They have the same orientation.
Uh-huh.
And the labels are done clockwise.
Right. You mentioned corresponding lengths, meaning that these lengths would be the one that are in the same position on the shape, on both shapes, right?
Right.
Okay.
Okay. So here's our next example.
And we have our object and image. And notice the object is larger than the image in this case.
Right. So what else do we notice right here?
Also noticing that we have both objects, corresponding points are going to a particular location in the origin.
X marks the spot.
X marks the spot.
All right. So what does this X? What is this location X? So what I'm seeing here, X is at 0, 0.
Right.
All right. So what else do we notice?
I also noticed that the orientation for both of them are the same. Same orientation. And also, if we should look at the image, the base of the image, the triangle being the image is what? 2 units.
2 units.
The length of that line segment. And the object base line segment is 4 units. So these are also proportional.
Right. And as you said earlier, so the object is the original.
Yes.
And the image is your result.
After
so based on what
transformation.
I'm seeing here, the object, we started off big.
Yes.
And now we're getting smaller.
While in the previous one, the object was smaller and then we had a bigger image.
Right.
Yes.
Okay, so let's summarize again. So go ahead.
So both triangles are similar and corresponding lengths are proportional. The distance from the center 0, 0 to each point on the image is a multiple of the distance from the center. And we'll talk about more of that as we go further into the lesson.
All right, awesome.
All right, so as was mentioned before, so we have proportional here, lengths, and notice that the distance from the center, which is marked by X, here 0, 0, is the distance from the center to the object is 1, 2, 3, 4 units, and from the image to the center, it's 2 units. So we notice, and if we should take the other line segment here extending from both corresponding points on object and image, the lengths would be proportional also, meaning
so
the
2
distance,
units there and 4
right.
on the object.
So on this side, for the image, the distance from the center, 1, 2, 3, and from the center to the object, the distance is 6.
I don't know because I'm wearing glasses, but clearly I'm seeing 2 new symbols on this diagram.
Ah.
What are these symbols called?
Okay, so we're looking here at theta, the angle symbol.
Okay. So basically what this is saying is that this angle here on the image is the same as the angle in the object?
Yes, the angles will remain the same, even though we see that the size of the two shapes are not the same. And I'm thinking to myself, then if the sizes change, what would happen to the area?
Well, the area should also change, right?
It should.
Right.
Well, we have a lot of things to investigate.
Sure. Okay, so let's move on.
All right, we could check our area concept on this to see if the area will remain or change.
Sure. And just for a quick recap, we know that the area of a right angle triangle is linked to the area of a rectangle. Right. So if I can find the area of the rectangle,
yes,
I simply halve that area to find the area of my right angle triangle.
Awesome.
So let's start with the object.
Okay.
So for the object, DE would be
2 units.
2 units, and we have a scale here that says that 1 unit is 1 centimeter. So DE would be 2 centimeters, and DF would be 4 centimeters.
Awesome.
So what would be the area of this triangle?
Well, you applying the rectangular, coming from the rectangle.
Right.
So if length times width would be 4 times 2.
Right.
The triangle is half of the rectangle. So half in that area would give the area of the object, the triangle here, to be half of 8 would give me 4 squared centimeters.
And we must remember our units, right?
Yes,
Okay.
yes.
All right, so for the image, AC would be 1 centimeter.
Yes.
And for,
AC
sorry,
would be
AB and AC would be 2 centimeters.
Yes.
So for this case, what's going to be our area?
The area for the rectangle would be 2 times 1, which would be 2. Half of that would be 1 squared centimeter area of the triangle, the right triangle.
So clearly, the areas are going to
Change.
Right.
The angles remain the same. The size of the angles remain the same. However, the lengths of the sides of the shapes change, and we also notice that the area
change
changes.
the area.
Okay. So we have been doing large to small and small to large. Okay.
So we're flexible right there.
Yes.
All right. So, Nikisha, we have been exploring enlargement.
Yes.
So let's look at some points that we think about so far when we're thinking about enlargement.
Awesome. So an enlargement, as we realize, is sometimes called a scaling or dilation. Remember, we talk about the pupil and we say the pupil dilate or undilated, so dilation. So it's a transformation that produces an image that is the same shape as the original but a different size, as we have discovered as we're going.
Okay. So a dilation or a scaling that creates a larger object is called an enlargement.
Right, a larger image. And therefore, on the reverse, if we should have a scaling that creates a smaller image, it would be a reduction.
All right. Now we have been exploring
Enlargement. And there are certain things that would have come up. And from our discussion, we would have realized that we have experienced enlargement in daily lives. For example, in our model trains, model cars, and model planes.
Right. So for the actual train
Yes.
and a model train,
Yes.
I can see we're moving from a
Larger
object to a smaller object.
The
Right.
models would be smaller.
And it could go the other direction as well.
Yes. So the overhead projector allows us to, as we're doing now, present small image from our computer screen, because everybody would not be able to see the computer screen. So we use our overhead projector to project the image so everybody can see.
That's also an enlargement.
And right.
We also have the zoom lens on our cameras, and we all have access to cameras on our cell phones, right?
The movie projector would do similar as the overhead projectors. All right.
Magnifying glass, we use it in science class.
Yes.
So we know the purpose is to make smaller objects larger.
Yes, because sometimes we have to be looking at cells.
And the same with the telescope, the microscope, and the binoculars that bring far objects closer.
So we can see clearly. The television. Now the television, I am sure when you're seeing me now on the television, that's not the same height as I am standing right here in studio.
That is true.
I am sure that height is much smaller, shorter than my actual height.
That is true. Can you imagine the actual height standing in your living room? Unless you're using those big screen. Well, I don't think they have any screen as big as...
No.
Okay.
So the television would have actually shrunken. They would have shrunken the object.
And finally, we have our photocopier. And you know that we use these, especially during exam time, when we have to roll off all those test papers and so on. So we can actually magnify the images, or we can shrink them.
Awesome. So basically, enlargement, it requires a center of enlargement and a scale factor. And these are two very important factors that will come into play when we're going to be carrying out our activity, when we're doing enlargement.
And for every enlargement, a scale factor, we're going to call it K, it must be specified.
Okay. And enlargement is described by its scale factor, and which is K, which is a real number.
Right.
And the position of the enlargement is described by the center of enlargement.
All right, so we're going to look at some properties of enlargement. So each side of the object is resized by a scale factor.
And remember, the object is the diagram with the letters that do not have the small markings on top, and the image would be that shape with the letters with the small little line at the top of them, called the prime. So the length of the sides remain the same as in proportion to each other, as we would have seen on the triangles.
Also, each line segment in the image is parallel to the corresponding line segment in the object.
Awesome, yes. And parallel meaning that they are going in the same direction, equal distance apart.
That is right. And all the angles remain the same in the object and its image. And we would have seen that in our exploration earlier.
Yes.
Let's look at some more.
Now, the center of enlargement does not change for that specific enlargement.
Right.
For that specific transformation, the center of enlargement would not change.
The length and the area of the object and its image do not remain the same, except when the scale factor is 1 or -1.
And we'll talk more about that further in the lesson. And also, enlargement is a direct transformation, meaning they do not flip or turn over. So, unlike reflection.
Right.
So, PQR, this diagram here, and P prime, Q prime, R prime are both labeled anti-clockwise, and we have to ensure that we pay attention to the labeling of our vertices when we have created the image. Okay, so we're going to start out. So we have mentioned that enlargement needs center of enlargement, and we also need a scale factor. So let's discuss the center of enlargement. So the center of enlargement, and notice here on this point, what would be our center of enlargement?
So clearly it's not the origin anymore.
It's clearly not the origin anymore.
All right, so what I'm seeing, it's at 1, and that seems to be 5.5.
Yes. So the fact that it is at this location and it's not here, it means that the center of enlargement can be at different places on the Cartesian plane.
Okay.
Just as with the lamp, when we were discussing the shadow, right. The lamp can be moved around. And if you remember, if when you're playing around with your shadow, with the light, if you move at different direction, move the light, your shadow will move as well. So it's the same idea with our center of enlargement. It's not static.
Okay.
It can be at different places on the Cartesian plane.
And as you just mentioned, the center of enlargement can be anywhere,
yes.
And we can describe it using its location on the Cartesian plane.
Awesome. Another interesting fact about the center of enlargement is that it can be on the object. So in this case, notice center of enlargement O is on the object, or it can also be inside or within. So notice O here is within the original shape. So as we said, the enlargement can be anywhere, because sometimes we're standing directly under the light, or shadow is right here within us. So it depends on where the light is. So the center of enlargement changes, and it can be anywhere.
Okay. So how do we find the center of enlargement?
All right. Now, the center of enlargement, as you say, can be found by extending lines from each vertices of the object and the image to a point at which they will intersect.
So we are matching the vertices and we're drawing line segments to see where they meet.
All right, so before we get further into that, now we're going to take a quick break. We'll be right back with more mathematics.
Welcome back to class time. We're looking at transformation geometry. Nikisha, let's pick up where we left off.
Yes. So if you are asking me how to find the center of enlargement.
Yes.
So here we have our center of enlargement at point O on both shapes. Now let us look at the first picture. So we have here at the base of this triangle, so notice that we have lines extending from the vertices of the 3 vertices on the triangle, 3 lines extending, and also we could call this our object and this our image, or whichever way we want
All right,
to.
I think we should call the smaller one our object.
All right.
And the larger one our image.
So notice, as I was saying, line is extending, a line segment is extending from the vertices of the triangle to the center of enlargement on both image and object. And at this point, where they meet or intersect is called our center of enlargement. Okay?
Okay.
And we'll be doing that when we get into the activities of the lesson. You'll see how we find the center of enlargement by extending lines from the vertices.
And I can see that in this case it's called O. Is it always going to be O?
No, your center of enlargement can be any letter.
Okay.
All right, so we mentioned that we need to have center of enlargement and the scale factor to do an enlargement.
Right.
So let us now look at the scale factor.
All right, so I'm looking at the smaller triangle, which is in light blue.
Yes.
And I'm seeing that the length of the base of this triangle is 2 units.
Right.
While for the larger triangle, the base, what's that base? What's the length of that base?
The length of that base would be 4 units.
So 4 units.
Yes.
So based on what we discussed earlier, I'm seeing that the relationship from 2 to 4, it means that the 2 was multiplied by 2 to get 4.
Right. So no, this triangle is twice the size of this one using the scale factor 2, because that's the proportion of 2. This is 2 times that, or we could say that this one is half of this size here.
Right. So basically, the scale factor describes how much larger or smaller the enlarged shape is compared to the original shape.
So best we see what the question is asking us to do. Is it asking us about the image or the object?
Okay.
So we have to pay attention to that. So let's talk more about the scale factor.
So here are some points to note.
Yes.
So if the scale factor is bigger than 1, the image is an enlargement.
Enlargement. So that means the image will be larger than the object. Remember that we said that the scale factor tells you how much larger or smaller the object and the image is. So if the scale factor K greater than 1, so 1, 2, so the previous example we had, the scale factor would have been 2, because the length would have been multiplied by 2.
Right.
So we would have gotten a larger object.
Now, if the scale factor is between 0 and 1, what's going to happen here? What numbers fall between 0 and 1?
We have our proper fractions.
So it's important to stress proper fractions.
Yes.
All right.
Or proper fractions.
So proper fractions fall between 0 and 1.
So I am thinking that if I multiply the line segment by a scale factor.
Let's use a half.
Let's use a half, yes.
Right.
So if I have the length of the line before to be 2 units, and I multiply that length by my scale factor 1/2, that would give me 1.
Right.
So my image would be smaller than my object.
And basically, anybody tell me a half of anything, me I think about less. I don't know about you, but...
Yes, because fractions is smaller than the whole. The proper fractions are smaller than the whole.
All right.
Yes. So if the scale factor is 1, so it means I'm going to be multiplying by 1. I'll get back the same thing, because when I multiply 2 times 1, I get back 2. If I 3 times 2, I get back 3. So it means the object and the image would be the same size.
That is true.
And they would be congruent in every way.
Awesome.
Okay, so we have been talking about scale factor and enlargement, necessary factors in carrying out enlargement. Let's see how we write it or note it.
So we're looking at the symbols here, right?
Yes. So if we have E, an enlargement with center of enlargement O, and as we said, it doesn't always have to be O. Can be
But
any
we're
letter.
using O for this particular example.
And our scale factor K, which is any real number. So here we have a diagram.
And here we have our notation. So how do we read this notation? So the E stands for enlargement. So it's an enlargement where the object AB
Yes.
is transformed or mapped to A prime, B prime.
Right, so these would be object, image. As I said, the image with this small notation above the letter line, the line there above the letter. All right, so our K, or scale factor. So if we're given a situation where we need to find a scale factor, we don't know the scale factor, but we're going to need a scale factor, so we need to find it.
But we have the image and the object.
We have the image.
So how do we use these two to determine our scale factor?
So we would therefore look at the distance from the center to a point on the image. So remember the center, we're talking about the center of enlargement, and we'd check the distance of that line from the center to a point on the image. So from O to B prime.
Or A prime.
Or O to A prime, what would be the length of that line segment. And we would also look at the distance from the center O to A, which is the object, and O to B, any point we can choose corresponding, and then we would divide these lengths.
So this seems to be something linked to ratio and proportion, right?
Right, because the sides are proportional. Awesome.
So we can also find a scale factor by comparing the length or a length on the image.
Yes.
So we are going to be looking at the line segment A prime, B prime.
Yes.
And we're comparing it to the same length or the similar length or
Yes.
corresponding length on the object.
Yes.
So AB.
Yes.
So when we compare them, how are they related? How are they connected?
Right. So that's how we would be able to find our scale factor. All right, so we have spoken a lot about a lot of things. I think it's time for us to practice to see if we really understand what we have been talking about.
All right, so here's our first example. We want to enlarge the triangle from the origin using a scale factor of 3.
And the origin here is our center of enlargement.
Right.
Using the origin as our center of enlargement. So we have our center of enlargement and we have our scale factor 3.
And those are the two important things that we need to do our enlargement.
Now, you had mentioned earlier, if my scale factor is greater than 1, I should start thinking what my object would look like, my image, would look like.
So right away I'm thinking it's going to be big.
It's going to be bigger than
right.
my image would be bigger than the object. And based on what we said, I'm thinking 3 times the size, because that's what the scale factor tells us.
So let's start off with the first vertex. Let's do the alphabet in alphabetical order. So let's start off with P. So how do we go about enlarging the shape starting with P?
All right, let's start by putting in our center of enlargement.
So our center of enlargement is at the
origin.
0,
0, and we are looking at point P. And notice that the distance from the origin to point P is 2 units. And if I should use my scale factor, is 3 units. Using my scale factor, so I multiply the length of the distance from center to point P by my scale factor 3. So that would give me 9.
Right. So if we do the same thing with point Q, so we're seeing that the distance from the center of enlargement to Q, there is
3 units.
3 units on the x-axis.
Yes. And I'd multiply that by my scale factor. And at 3 times 3 would give me 9. So it would be 9 on my x-axis.
And it must be on the same line segment, right?
Yes.
So you see where we extended this line segment. So we know that, yes, the point is going to be
At 9.
at 9.
9, 3.
Right.
But how do I know that it was going to be 3 at the Y? I calculated the 9 by multiplying 3 times 3, giving me 9 here. But how do I know how high up I should go on my Y-axis?
All right, the thing is, if you had the grid, you could easily, as I said, you could draw the line segment and use that 9 only. But what if you didn't have the grid?
Right.
So what are we going to do? So I can tell that for point P, the
Yes.
Y coordinate would have been 1. So the same thing is happening with the 1. I multiply the 1
By the scale factor?
The scale factor of 3,
Okay.
which gives me 3.
Okay.
So therefore, the coordinates of Q prime would be 9, 3.
Okay, awesome. Because the Y coordinate for Q was 1, and I would multiply that by 3, and it would, awesome.
Right.
Awesome.
All right, so finally, let's look at R. What's going to happen to R?
So, R, same thing, measure my distance from center of enlargement to point R, 1 unit, multiply that by my scale factor, 3. So the distance from center, remember, it's from the center to, would give me up to 3 on the X and 3 on the Y. So notice R was at 1, 1. And if I multiply those two by
Multiply
3,
by 3.
we now have 3, 3. Awesome.
All right, so now we have our 3 points for our
Yes.
image. So what's left?
We can connect the dots. to
Simple as
complete the
that. So
shape.
let's connect them.
So we have P prime, R prime, Q prime. And now we
guess
have our
what?
image.
Just as I said, the image is obviously bigger than the object.
And 3 times larger, I must add.
Exactly.
Let me just check. Let me just double check. I remember we must always check our work.
Okay.
The line segment PR is 2 units. Let's see if line segment P prime, R prime is 3 times that length.
Okay.
So 1, 2, 3, 4, 5, 6. Awesome. 2 times 3, 6.
And if it works for one?
It will work for the others.
All right.
Awesome. So this is nice, interesting.
I'm having fun so far.
Me too.
All right, so our second example, just like the first, but for this one,
We're using a quadrilateral.
Okay.
So we have more points to enlarge.
so here we have our instructions. So again, we are enlarging from the
The center.
center, which is 0, 0. And the scale factor in this case is going to be 2.
2. So the scale factor is 2, greater than 1. I know that my image is going to be larger.
Right.
2 times larger, in fact.
That is true. All right, so again, we start off with the first letter in alphabetical order. So let's start off with J.
All right.
So I'm C. So I'm going to use a little shortcut you taught me a while ago.
Yes.
So I'm using J. J is located at 1, 1.
1, 1.
So since the scale factor is 2, I'm going to multiply each of these numbers in the coordinates by 2. So 1 times 2 gives me
2.
2. So I'm thinking that the location of J prime is going to be at 2, 2.
2, 2.
And I'm very positive about it.
Okay.
I hope it works.
We're not in this a try to feel. We are exploring.
All right, so let's see.
Yes. You're
Oh,
good.
yes.
Good. And if we should check with our ruler, the length of line from center to J would have been 1 unit.
Right.
And if we multiply that by our scale factor 2, our length of line for J prime, 2 units.
Okay, so
we
it
can
works.
apply multiplying the coordinates.
So I guess we can move faster.
Yes.
All right, so let's try K. So I'm going to do K and you do the other 2.
All right.
So for K, the coordinates are 3, 1. So if I multiply each of these by 2, 3 times 2 gives me 6. 1 times 2 gives me 2. So the location of K prime is going to be
6 on the X and 2 on the Y. So let's take
Right.
L. For L, the coordinates 2, 3, 4. Multiplying that by our scale factor, 2 times 2 would give me 4, and 4 times 2.
So we're multiplying 2 times 3.
2 times 3, thank
Right.
you.
So 2
6.
times 3, 6.
We have to be careful, thank you.
Right.
And 2 times 3 would
And
give me 6, and 2
2
times
times
4
4
would give me 8.
All
So I'm
right.
looking at 3, 8 for L.
And I'm going to pull a quick one on you right now.
Why?
So if we're drawing a quadrilateral, and clearly this is a rectangle.
Yes.
I'm seeing that we have 3 points already. So without even doing any more work, I'm going to say that the final point is going to be
Show off.
located at
Show off. Just
2, 8.
Just go and show off.
2, 8.
All right. Let's see. We should just show off. So now that we have our 4 points, let us connect the dots to form our image. And we have enlarged the object MJKLM from the center of origin
By a scale factor.
by a scale factor of 2.
2.
So this image is twice the size of the object.
It's getting so easy for me
Yeah,
now.
we can move faster. Yeah.
All right. And we all know the
Yes, the coordinates.
of each vertex. All right. So, Nikisha, we're looking at scale factors, and we're going to be talking about positive scale factors.
So we have been using positive numbers so far.
Right.
Notice that when we enlarged using positive numbers, I noticed that the object and the image were on the same side of the center of enlargement. And that is one point for all when we enlarge by a positive scale factor. The center, the object and the image fall on the same side of the center of enlargement.
You know, I didn't notice that one.
I know you
that
didn't.
one missed me.
All right. So what do you think will happen if we have a negative?
So since they're opposite, positive and negative are opposites, I'm thinking the opposite thing would happen.
All right.
So instead of them being on the same side, they're going to be on opposite sides?
It's a possibility.
All right.
All right, so if the scale factor is positive, as was said, both the object and image are on the same side. So we can move a little faster
Okay.
here. And we notice that when we have a scale factor that is greater than 1, it increases the size. Okay? So let's look at enlargement with negative scale factor.
So this is the one I want to see what's going to happen now. So for this example, I'm seeing where we want to enlarge the shape by a scale factor of -2. And we're told that the center of enlargement is 5, 5.
So it's not in at the origin, 0, 0.
Okay. So what's the first step?
First thing, let us plot our center of enlargement, which would be at 5, 5. And that's where it would be. Following that, we would choose a point from the object. Keep going. And from that point, draw a line segment to the center. Then, as you can see here, from A to the center, 5, 5, then we'd measure the length of that line segment. And when we measure that length, it would be 1 unit from A to the center of enlargement. And as we were doing before, multiply this length by the scale factor, which was -2.
Right.
However, so the distance was 1. So we're not going to use the negative sign. We're just going to work with the number itself.
So we're looking at the size, just the size.
Just the
for
size.
now. Okay.
All right, not the direction. So we're going to multiply the distance by the scale factor, and that would give us 2. Now, these 2 units would transform point A. All right, keep going. Go ahead. All right, so from the center of enlargement, we would measure 2 units from the center of enlargement. All right? So, and we would repeat that for the other points. So you would measure from each point to the center of enlargement, multiply the length of that line segment by the scale factor, and then draw that line segment from the center of enlargement.
And finally, we're going to do what now?
So
So
we'll come back to that when we come back from the break. Welcome back. Now, before the break, we were looking at enlargement with negative scale factor. And what we realized or discovered was that the points are falling on the other side of the center of enlargement. They are not on the same side as the object. So it means our image will be on the other side of the center of enlargement when we enlarge with a negative scale factor.
And not only that, Nikisha, but I'm seeing this looks upside down to me.
Yes, the shape would have been inverted, and that's one of the things with enlargement with negative scale factor. The vertices would, the lines, everything would be inverted. The whole shape would be inverted. And notice that AC here in the object was at the bottom, now it's at the top, CA. Notice the direction also that it is labeled one clockwise and the other anti-clockwise.
So let's explore some more.
Yes. All right, so we have looked at the negative scale factor. So let's move on. So we notice that the object and the image fall on different sides. So let's move on to the fractional scale factor.
So this would have been another
example of the negative scale factor.
So clearly we can see what's happening here.
So we just find the length from a point to a center and then multiply that length by the scale factor, ignoring the negative sign, and that would measure that distance from the center, and that would give you your image points.
This one is a bit hard to identify though, because I can't tell it's upside down unless I look at the
label is.
Right.
All right, very good. So just remember that.
Okay, so fractional enlargements.
Fractional enlargements, as was mentioned before, fraction is not the whole, it's part of the whole. So it therefore means that my image should be smaller.
And we're speaking about?
Real, proper fractions.
Right. All right, so for this one, we're told the scale factor is 1/3.
Yes.
And the center of enlargement is 1/1.
1/1. So center of enlargement, different position on the Cartesian plane. And the same rule apply. Take the length, choose a point on your object, measure that length of line segment, and multiply that by your scale factor.
Which is 1/3.
1/3. So this line segment here is 3 units. So I'd multiply
by 1/3.
By 1/3.
And that would give me what?
1.
That'd give me
1/3 of 3 would be 1. So that is telling me that from the center of enlargement, I need to have A prime to be 1 unit.
Right.
1 unit from the center of enlargement.
And we're going to repeat this for all the other points.
Yes. And notice these are positive, so it means that the object and the image would fall on the same side of the center of enlargement. All right? Going a little bit too fast. So we can see that when, let's go back a little.
So when a shape is enlarged by a scale factor between 0 and 1.
Which should be our proper fractions.
Right. So the image is going to be smaller than the original shape.
Mm-hmm. We're not going to do this. So how do we describe enlargement? We describe enlargement, let's see, notice we do not have center of enlargement here, and we do not have scale factor.
So I'm thinking that to describe the enlargement, since we need the scale factor and the center of enlargement to do the enlargement, to describe it then it must be that we're giving the scale factor and the center of enlargement.
But remember, how do we find the center of enlargement? Because we usually start off with the center of enlargement.
Yes.
So let's find the center of enlargement. Quickly, we'll just choose a point, corresponding points on both object and image, and draw a line segment, continue, draw a line, and we'd extend this line past the shapes. And then we'd also choose another corresponding point, two corresponding points, one on the object, one on the image, and draw a line segment and wherever, and we'd extend them until these two lines meet.
So
Now, at
wherever
this
these two line segments meet, that's where you have your
center of enlargement.
center of enlargement.
So at this point, 6, 2, this is where the center of enlargement would be, where the two line segments meet. Awesome. So we have our center of enlargement.
Okay.
So now we need
one
to
more
find
to go.
the scale factor.
Right. So to find the scale factor, so I'm going to use what we just discussed earlier. So to find the scale factor, I'm going to be looking at the lengths of corresponding sides. So we're going to look at AB and A prime, B prime.
Right.
So in the object, AB would be 4 units.
Yes.
And in the image, it would have been 2 units.
Click.
So when we compare these two, we're comparing the image to the object. So we can see here that the scale factor would be 1/2.
Awesome.
So how do we put this in sentence form? Wrapping up now, how do we describe the enlargement?
All right. So we would describe that enlargement by saying that the shape has been enlarged about 6/2 with a scale factor 1/2.
Okay, awesome.
1/2. And notice that the scale factor is half. So which one of these would be the object?
All right, so if the scale factor is 1/2, I'm thinking that the object is going to be the smaller one. The object, the image is going to be the smaller. That one caught me.
Yes.
So the image is going to be smaller.
Yes.
The object is going to be large. You caught me on that
Yeah,
one.
I'm so sorry. But that's okay. So that's what we need to pay attention to, our scale factor, and or so that we know which one
Is the
what
object,
the image would
which
look
one
like.
is the image.
Yes.
All right.
So right here, our image smaller. All right. So we're going to summarize what we would have been discussing so far. We're not going to look at these ones. These are just another situation. And this CSEC question, where we were asked to use the center of enlargement at 6/6 to enlarge here, and we have a scale factor of 2. So using the same steps that we would have used before.
And it's nothing difficult. We were doing these examples all along. So 2 marks,
All right.
2 easy marks.
So let us go to the first slide of the summary, because I think that's all we have time for. So we have said a lot of things. An enlargement is a transformation of an object that has the same shape but changes the size of the object.
The scale factor tells how many times larger or smaller the image is than the object.
Okay. And also, the angles of the object and its image are the same, but the lengths of the sides are increased or decreased.
An enlargement produces similar shapes.
Yes. And when changing the size of an object by an enlargement, we do so from a point called the center of enlargement.
And for any enlargement, the distance from the center of enlargement to a point on the image is equal to the distance from the center of enlargement to a corresponding point on the object multiplied by the scale factor.
And we'll stop here.
And that's all we have time for today. Class time resumes tomorrow at 9 a.m. with more CSEC mathematics. Until then, keep safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.